Yo guys, how's everyone doing today? Bhuvan here, ready to break down a super important topic. Thermodynamics. It's one of those subjects that sounds super complex, but trust me, it's actually pretty cool once you get the hang of it. Ghabrana nahi. It's not as scary as it sounds. We're going to take it step by step, and by the end, you'll see how fascinating it really is. Thermodynamics simply ये है कि energy कैसे heat और work में बदलती है. Imagine it as the magic behind how energy transforms and does work. It's like the behind-the-scenes action of how things get hot or cold, move or stay put. Zara socho. Every time you see a machine working or feel the warmth of the sun, thermodynamics is at play. Ever wondered how your refrigerator keeps your food cold or how a car engine gets going? These everyday miracles are all thanks to thermodynamics. Yep, that's thermodynamics in action. It's not just theory, it's something we see and use in our daily lives. ये वो साइंस है जो एक्सप्लेन करता है कि कैसे एनर्जी फ्लो करती है और चेंज होती है हमारे यूनिवर्स में. From the smallest atom to the vastness of space, energy is constantly moving and changing forms. So, buckle up as we dive into this fascinating world of heat, work, and everything in between. We're going to explore some cool experiments and real-life applications. Trust me, by the end of this, you'll be able to impress your friends with your newfound knowledge. Let's get started. Ready to become a thermodynamics pro? Let's dive in. First up, let's talk about temperature. It's something we encounter every day, whether we're stepping outside to feel the sun's warmth or shivering in the cold. हम सब जानते हैं कि गर्मी और ठंड क्या होती है, right? We all know what it feels like to be hot or cold, but have you ever wondered what temperature really means? But what exactly is temperature? It's more than just a number on a thermometer. In simple terms, temperature ये बताता है कि कोई चीज कितनी hot या cold है. It indicates how much heat energy an object has. It tells us the average kinetic energy of the molecules within an object. The more energy they have, the faster they move. Imagine a bunch of tiny balls bouncing around. These balls represent the molecules in any substance. The faster they bounce, the hotter the object. This is because they have more energy and are moving more vigorously. The slower they bounce, the colder it is. Less energy means slower movement and lower temperatures. Temperature is like a speedometer for these tiny balls, telling us how fast they're moving on average. It's a measure of their kinetic energy. We measure temperature using different scales like Celsius, Fahrenheit, and Kelvin. Each scale has its own way of representing temperature. But no matter the scale, the concept remains the same. Temperature is all about the energy of those tiny, jiggling molecules. Understanding this helps us grasp why things feel hot or cold and how we can measure and control temperature in our daily lives. Next up, we've got energy. Energy वो fuel है जो चीजों को चलाता है. It's the ability to do work. And in thermodynamics, we're interested in how energy is transferred and transformed, especially as heat and work. Think of it like this. You need energy to lift weights, right? That's work. Similarly, you need energy to heat up your coffee in the morning. That's heat transfer. Energy is the driving force behind all these changes. Energy comes in different forms. Kinetic energy, energy of motion. Potential energy, stored energy. Thermal energy, heat energy, and more. Thermodynamics helps us understand how these different forms of energy interact and change. Now let's talk about entropy. Entropy thoda tricky concept hai, but bear with me. It's one of those ideas that can seem a bit abstract at first, but once you get it, it makes a lot of sense. Entropy is a measure of disorder or randomness in a system. Think of it as a way to quantify how mixed up or chaotic things are. ये measure करता है कि चीजें कितनी messy या disorganized है. Imagine your room. When everything is in its place, it's easy to find what you need. When it's clean and organized, it has low entropy. Everything is predictable and in order. But when it's messy with clothes and books everywhere, it has high entropy. You can't find anything, and it feels chaotic. Everything in the universe tends to move towards higher entropy, towards more disorder. This is a natural tendency, like how a room gets messy over time if you don't clean it. Entropy is important in thermodynamics because it helps us understand the direction of spontaneous processes. For example, why heat flows from hot to cold, or why certain chemical reactions occur on their own. Things tend to happen in a way that increases overall entropy. Ice melts into water, and a campfire burns down to ashes, both increasing disorder. It's like the universe's way of saying, let's get messy. So next time you see something getting disorganized, remember, it's just entropy at work. Section 5. Isothermal processes. Keeping it steady. Now that we've covered the basics, let's dive into some thermodynamic processes. First up, we have isothermal processes. Iso means same and thermal means heat, so isothermal processes happen at a constant temperature. Imagine a balloon filled with air. If you slowly compress the balloon while keeping the temperature constant, maybe by putting it in a water bath, that's an isothermal process. The pressure inside the balloon will increase, but the temperature will stay the same. Isothermal processes are important in many natural phenomena and engineering applications, like the melting of ice or the operation of a refrigerator. Section 6. Adiabatic processes. No heat exchange allowed. Next, we have adiabatic processes. Adiabatic means no heat transfer. So, in an adiabatic process, no heat is exchanged between the system and its surroundings. Imagine a thermos flask. It's designed to keep your coffee hot by preventing heat exchange with the outside. When you pour hot coffee into a thermos, it undergoes an adiabatic expansion, cooling down slightly as it fills the larger volume. Adiabatic processes are important in many areas, including the workings of engines, the formation of clouds, and the study of sound waves. Section 7. Isobaric processes. Constant pressure action. Moving on, we have isobaric processes. Iso means same and baric refers to pressure. So, isobaric processes happen at constant pressure. Imagine heating a pot of water on a stove. The pressure inside the pot remains constant, but the volume of the water increases as it heats up. This is an isobaric process. Isobaric processes are common in everyday life and industrial settings, such as cooking, boiling water, and many chemical reactions. Section 8. Isochoric processes. Volume holds the key. Last but not least, we have isochoric processes. Iso means same and choric refers to volume. So, isochoric processes happen at constant volume. Imagine a sealed container with a fixed volume. If you heat the container, the pressure inside will increase, but the volume will remain the same. This is an isochoric process. Isochoric processes are important in understanding the behavior of gases and in applications like pressure cookers and internal combustion engines. Section 9. Thermodynamics in action. From refrigerators to rockets. So, we've covered the basics of thermodynamics and some important processes. But where do we actually see these principles in action? The answer is everywhere. Think about your refrigerator. It uses a refrigerant to absorb heat from the inside and release it outside, keeping your food cold. This is based on the principles of heat transfer and thermodynamic cycles. Or consider a rocket launching into space. The powerful combustion of fuel releases a tremendous amount of energy, propelling the rocket upwards. This is a dramatic example of energy conversion and thermodynamic principles at work. Section 10. The grand finale. Thermodynamics rocks. So there you have it, guys. Thermodynamics might sound like a mouthful, but it's really just the study of how energy works. And it's everywhere. From the way we cook our food to the way stars shine, thermodynamics is the driving force behind countless phenomena in our universe. So next time you feel the heat, remember the amazing world of thermodynamics at play. It's the science that makes our world go round, literally. That's all for today, folks. Stay curious and keep exploring the wonders of science. Peace out.